Welcome back to Balvigan Bharti with your mentor Abhilash Sarkar. Now, going to next in the matrix. Prior to that, I will definitely want to clarify a few more things that could pop up as a doubt in your mind, and that has to be described in a one point. A few things are that the inverse inverse of a matrix can be done for a square and non-singular singular matrix only. Okay, this is one declaration that has to be understood. Square means where your row and column are same. With that matrix, the matrix that you will start with has to be of square matrix and non-singular. That should not carry only one element. Okay, so that's the declaration. Second is that identity or unit matrix should be should or you can say the must be square matrix. Okay, so that you can use your common sense, because diagonal, when the prime diagonal has to be all of equal value, that is equal to 1, you cannot think of a rectangular matrix and you can find a diagonal. That in real rectangular figure, that diagonals are there. In real diagonals may be there, but when it is coming where we have to cut across the elements. Now a rectangular matrix can be of form this. Now we cannot find any common diagonal. We cannot cut all the elements in the diagonals this way, so you have to miss something. But whereas if it is something this kind, so definitely you will find a common diagonal. So this is the common sense. From there we can say that the identity matrix cannot be of any rectangular kind. This has to be a matrix, has to be a unit square matrix. Okay, these are the two things. Another thing I'm missing, it has to be said. What is that? Another thing is that while I calculating the matrix, inverse of a matrix by the method of elementary transformation method, where there I am doing several operations. So you can also think how I can change the form of the matrix, because that the same way you are doing. Because if I say this is same way when we are solving some equation. Let's say the z is equal to 3x minus y plus 5z is equal to 5, and your, let's say, x minus x plus 2y minus z is equal to 6. Now while you are doing, these are the number of equation as per their initial position. Now I can take it to the number one equation by this. So there is a change of row, interchange of row into row 2. So we are changing, so that means all the values are changing. So at the same time, the left and right hand side, the matrix, we are imposing the same operation. So this I can do in case of solving by elimination or that comparison method there. Now multiplying any row with the same number, so this as also doing for elimination. As a I have to eliminate z from here. What I have to do, multiplying the whole thing on the right left hand side of the 5 and deducting from this to get eliminated the part that I have to make 0. So this same thing I am doing, but I am doing row wise. Okay, to eliminate this. Okay, this can also be done here column wise. Okay, so column wise, if I eliminate z, I will eliminate 2, and now in column wise, if you eliminate, you have to make some arrangements where there both the things can be eliminated together. Okay, so this can be done, and column wise shifting also possible. If I put z here and y here, that will not change the equation. So whatever operation I am doing, the same operation in case of I am solving by the elimination or comparison method, I am doing the same thing. So this is nothing different. Only thing is I am doing with the single part of it where I am calculating, but that operation is I am implementing with both the sides and all the things. Understood? Okay. So this has to give you some clarification, or you can be in a you can come out from the state of doubt. Okay, so this need to be discussed. That's why I have described. Few things further to be discussed is these are some secondary rule, or you can say the byproduct of the main rule. First one is, it's saying that determinant of A cross B, that means product of two matrix. After getting the product value, if I take the determinant of that must be same as individually. If I take the determinant A and if I multiply with the determinant B, that will give the same result. This is the rule. So if I want to get it, to give some example, so that so let me take some example of any matrix. Let's say whatever coming in mind. Let's say I am taking two matrix 2 1 3 3 2 1 1 2 3, and the second one, let's say B, I am taking as the reverse of that I am taking. Let me take 2 1 3 and 3 2 1. Just I am just shuffling the numbers. I am just now first I will do the product of these two, then after I will take the determinant of that. So product means I have to multiply row into column. For first row I have to complete this, second row and third row. So 2 into 1 2 plus 2 4 plus 9. 4 plus 9 is 13. Okay. 2 into 2 4 plus 1 5 plus 6 11. 2 into 3 6. 6 plus 3 9. 9 plus 3 12. Okay. Now second row, 3 plus 4 7 plus 3 10. 3 into 2 6 plus 2 8. 8 plus 2 10. 3 into 3 9. 9 plus 6 9 plus 6 15 plus 1 16. 1 plus 4 5 plus 9 5 plus 9 14. 3 plus 6 9 plus 3 9 plus this will come 2 plus 2 4 plus 6 10. 3 plus 6 9. 9 plus 3 12. Now find the determinant of this. So what is that? 13, this 120 minus 160 minus 11 into then this and this 120 minus 14 into 16. Let me take 14 into 16. 64 6 16 plus 6 224. 224 plus 12 into 100 minus 140. Okay, now we calculate this. 13 into minus 40 minus 11 into minus 104 plus 12 into minus 40. Now this minus 40 and minus 50 come together, 13 plus 12, it will give you 25. So I will make it 25 and I will rub this part. So the answer will be, this is minus 1000 and this is minus plus 11 4 is 44, 11 1 is 11. So this will give you how much? This minus 1000, it will be 144. So remember this 144 for delta determinant of the product. Now individually I will take the, so this become 144 answer. Now I will take the determinant of, this will give 2, 6 minus 2 minus 1, 9 minus 1 plus 3, 6 minus 2. So this is equal to 4, 8 minus 8, 4 plus 12. So this is 12. Now this is 12. Now we'll go for B. Okay, so B, if I calculate, this is 1 into 1 minus 6 minus 2 into 4 minus 3 plus, no sorry, 2 into 2 minus 9 plus 3 into 4 minus 3. So this is equal to minus 5 minus 7 plus 14 plus 3. So this is also equal to 12. So this is 12. Now if I multiply delta A, determinant A into determinant B, I will get 12 into 12, that is equal to 144. Now it's already this, so you can see the results are matching. Okay, so this is one. Another one is there which tells so now you already have A into A inverse is equal to identity matrix or unit matrix. Okay, now the first rule, as I proved, A into B is equal to determinant of A into determinant B, that I have proved. So now if I apply this to this, determinant A must be equal to determinant of I, because these are all matrices. Can assume this is AB and that is equal to the result of this determinant. Okay, now if A and B are inverse to each other, means B is A inverse if I say, so this can imply, because ultimately when you multiply A into A inverse become identity and this will become delta, this will become determinant A into determinant A inverse, and this, if A is equal, B is equal to A inverse, so this will turn into identity matrix, and identity matrix determinant is value is 1. You know the determinant of identity matrix is value is 1. You can try it. Determinant of I, that is equal to determinant of the matrix 1 0 0 0 1 0 0 0 1. Okay, now if I take this determinant 1 into 1 minus 0 is something plus 0 into something, so ultimately this is equal to 1. Okay, this is very easy to understand. So this will determinant of identity matrix is 1, so you can write determinant of A inverse 1, or you can say determinant of A is equal to 1 of this relation also implies whenever it is required. Understood? So I will end up here. For the remaining, I have to prove some other things are there. So that okay, let me take this. As you know that A transpose of transpose is equal to what? A itself. The same thing happening with inverse also. If I take the inverse twice at a time, means consecutively take, that will bring back the same way that transpose can bring you. So this is one means rule. Okay, this can be proved. This I will prove. And the other one is, if I take inverse of a product, that will be A inverse in the order, the same as if I compare with the transpose, that was order being changed during, I make it separate. So B is coming first. So the same is with the inverse also is following. So this I will also explain. The third is A transpose. This is a mix of these two, these tails. A means you can do either. So if A transpose inverse, you have to calculate. First you can do transpose and then make inverse. That will give you the same result. So this is the three corollary or byproduct of this. So the first one is this one, second one is this one, and third one is this one. So these three I will prove, or you can prove yourself by taking some example. Okay, so that I will do in the next episode. Okay, so thank you for now.